Hi, welcome to Module 4, where we are going to take a deep dive into the basic concepts that are around generative AI. I'm assuming you know a little bit of natural language processing. If you might have known what is NLP and what are the libraries that are used in it, embeddings is the word you must have heard. Vector embeddings is something that we're gonna talk about in this particular module, and we are also going to go a step ahead and understand how search works within the LLM and the RAG application concept basics, right? So let's dive in. And if you remember our module one, where we talked about the evolution of AI, how everything is about mathematics at the end of the day. Mathematics, when I say it's about converting the data, which is in image format or document or word format, or in a video format or in a audio format, into a mathematical vector that can represent the actual data. So if I have a data, I can't really represent it in a mathematical vector to its entirety. I might not always. So it becomes an approximation, and using this approximated vector embedding, we'll be using it further to, you know, do some search on it or do some prediction on it, and we can play around it using the AI model that utilizes this representation of the actual data. Let's go further and understand how it looks like. So, let's say I have a text called canine companions say. This is a unfinished sentence, and when I use an embedding model on top of this text, it might be represented as the one-dimensional vector that you are seeing on your right-hand side of the embedding model. Likewise, feline friends say is represented as another vector index, and bovine buddies say this text is represented as the vector index that is not similar to the above two, but eventually they are all mathematical vectors. So what exactly are these embeddings? As I told you, it is the numerical representation of the data that we have, and it captures the semantic meaning of it, not just the words. So when it comes to the data that is related to the text or language, what happens is that um, we need to understand the context of the word that is being used so as to preserve the originality of the data, right? That's where we spoke about LSTMs. So beyond that, if I want to have it stored somewhere and have it represented using an embedding, that is where we convert the data of text into this vector embedding. So vector embeddings are having this kind of a meaning, not just the word. For example, let's talk about king and queen. So these two are nothing but the representation of husband and wife who are in power, isn't it? So they belong to the closed vector space. So king and the meaning around it or the context around it is being stored along with the word. Likewise, the negative example, if I have to give you, let's think of apple. When I say apple, it can be either fruit or it can be also a company, the Apple company, right? So the embedding should be representing the apple in its entirety, not just the word. Now, how do these embeddings work? So, as I told you previously, I have a list of steps given to cook or to create um, coffee, to make a coffee, right? So what would be the steps? Cup of milk, or after that you add coffee beans and then you add sugar, etc. So all of these steps can be represented as an embedding vector that you're seeing on the right. So what happens after representing them as vectors? Like what's the exact use? So when we have the embeddings with us, we can use it for semantic search. Like as I said, let's say I have a cookbook where I have different cuisines and I have the guide to make it. And if I have this guide as a vector embedding, I wanted to search how to make coffee, right? So when I have to search it, I can just look up in these mathematical representations and pull everything related to it, right? So that way our retrieval becomes easy, and uh, we will be able to use it in no time. Now, where are these employed in? You can understand them in your recommendation systems. Let's look at our YouTube homepage. It mostly recommends what we have previously watched plus what we have searched. So there we are using this vector embeddings and semantic search. We use similarity search in some places, and RAG pipelines, which is our next module where we dive deep on the basis of these vector indices. Now, let's take a step back and let me give you one more example on how semantic search works. Take a dictionary. So, how does a dictionary gets printed? It has all the words in alphabetical order A, B, C, D, E. Now you want to search something that starts with B. So what do you do is you don't go by each record from the beginning, like all the words that are starting with A, isn't it? You instead jump directly to B, which represents the set of words that start with B. Correct? So that way the semantic search works. That is called the semantic search. Semantic can also be told as a layer, right? Now, if you see a dictionary, it has initial layer of the starting letter of the words as a layer, like A, B, C, A to Z, right? Now, when I said I wanted to retrieve a word that starts with B, I can directly go hit all the words that are there with starting letter as B, correct? So that's how our document retrieval works. And to help you understand how it looks like when plotted, different indices. So when you see your cat, kitten, dog, houses, when you see those set of words, you see that cat, kitten, dog are nothing but animals. So they belong to the closed vector space, as in they are marked close by, correct? Like this. Houses is a completely different word, so it is far away in a vector space. So when I have all of this in one sentence, I need to bring them into one context. I mean, I need to bring them into one area so that I can do some semantic search. Now let's have another set of words as let's say there's a sentence that involves all of these words: man, woman, king, and queen. Okay. So when they are reduced from this seven-dimensional to two-dimensional, they look like this. So what's the actual difference between man, woman, and king and queen? Anybody can be man and woman, but to be king and queen, it needs power. So that's why they are staying apart. Now, so when there's a pile of sentences involving these words. So they are represented as vectors, like as you see here in a two-dimensional space. Now, when I have a database of all these sentences, and let's say I have to know about king, right? let's say, I want a sentence that involves king, right? And you're searching on top of this whole corpus of words. What happens is how the semantic search works, it directly goes to this place and retrieves this set of sentences. It won't touch this sentence. That's where the efficiency of computation comes in, right? So that is the huge benefit of having embeddings and doing a semantic search. Now, let's come to the application part. How do you do that? So there are so many popular embedding models. For example, OpenAI offers text embedding tree, small and large. Then there are Hugging Face sentence transformers that are freely available, where you can just grab one of the sentence transformer and play around with it. Again, Azure OpenAI embeddings combined with cloud offerings, where it gives you an complete independence within the cloud environment. You don't have to bring something out of the cloud environment. Likewise, you have NVIDIA that is currently offering models for you to utilize them in the form of NVIDIA Triton, etc. So these are the popular embedding models using which you can reduce the entire data into small chunks of embeddings. Let me show you one image. Yeah. So there are multiple documents or texts. We use certain embedding models that I mentioned previously, and they become vectors. And eventually, these vectors, when plotted in a three-dimensional view, it looks like this. As you can see, each color represents each kind of a category of words that the embedding model decided to place them accordingly, right? So that's the use of embedding model. And when it comes to your reducing the data into vector embeddings, we use this embedding model. Now, once we have all these embeddings, right, what do we do now to do semantic search? That's when we start storing these embeddings in something called vector databases. So there's a huge difference between a normal database that you must have heard versus vector database. Vector database is specifically for storing these vectors and allowing us to do semantic search. So these are used for fast similarity search. So in our previous example, when I asked about king, it immediately went into that area where man, woman, king, queen were discussed in that data versus cat and animals, etc. Right? Likewise, coming back to the vector databases, we have multiple vector database offerings from starting from Microsoft Azure to different companies like MongoDB, etc. So we have Pinecone, VV8, Fires, Azure AI Search, as I told you, from Microsoft. So these are the different vector databases that we can employ to store the embeddings. Now, how do this embeddings plus searching work? Let me give an example. Now, we have a query saying find documents about electric cars. So when I say documents, it's not our English documents, but the documents is a terminology that we use when it comes to the vector database. So vector embeddings are stored as documents within the vector database, right? So I want to find documents about electric cars. So what happens in a vector database is that the first thing that happens is to match the documents with EV, Tesla, battery powered cars. So these are the texts that describe the EV, right? Electric cars. So it tries to match it with these keywords, and the semantic understanding beyond these keywords are brought out, and those documents will be fetched as the result. That's how embeddings work. Now let's dive in more into this embeddings plus semantic search flow. So how do this work? Um, First, we create an embedding query like I showed you in the previous example. Compare them with the stored embeddings that we already have. Retrieve the top matches. So there might be multiple matches, but we try to retrieve the top matches and pass the retrieve documents as a context to LLM so that LLM will be able to summarize it or reproduce it as an answer to your question or query. So that's how your embeddings plus search flow works. Let's do one review on the entire thing that we just learned. We have data. Let's say we have huge amount of data in multiple PDFs or .doc Word files. Now we use an embedding model on top of this data to convert them into vector embeddings. Basically, these vector embeddings represent the actual data. Now, after we have these vector embeddings, we directly insert them into the vector database where they sit in the form of documents. Now, I have a query which belongs to this corpus. I am using embedding model to convert this query into vector embeddings. Once this query is converted into vector embeddings, we compare them with the existing documents in the database and try to match them with the similar aspects or vector documents that are there in the database. Once we have matching results, we arrange them as top five similar vectors. Now, if I add an LLM here, what happens? So, if I have an LLM here, what happens? Now, what happens is that this LLM will summarize and respond to the user as based on the query, you will get the response. So this is how embeddings and semantic search work in a nutshell. And this is the main building concept of our RAG applications. So let's look into some example use cases. So as I told you, embeddings and semantic search help us in having an semantic search engine just to search on these vector indexes as a vector documents as a developer or chat with PDFs. We have been talking about it and code or documentation search. Sometimes we have too many repos that we wanted to, go ahead and search for a particular code from among multiple code repositories or e-commerce product recommendations. I spoke about YouTube, but you can also think about Amazon. It also works on this concept. Now, in an enterprise Gen AI application, how does this come into play? Let's look into it. Any company will have its own internal data within their company. So this internal data is sent to an embedding model. As you see, this embedding model will convert it into vector documents, and they are stored in a database. Now what happens is we use an LLM so that as I told you, it will be able to summarize the output from this semantic search that we're gonna do. So when there is a semantic search, what happens is the query comes in, it goes to the embedding model, it then goes to database to search. After searching, it will then go to LLM to summarize it. Once that summary is with us or it is rewritten, our enterprise Gen AI app might have some security compliance and some guardrails so that it will pass the answer and gives it back to the user. That's how your enterprise Gen AI app works. So, what are the key takeaways from this? Embeddings capture meaning, but not just words. They capture words and also meaning around it. What it helps is to enable semantic search and similarity matching, and it is the core building block of RAG and Gen AI applications. Let's see this in action in our demo. Thank you.